The sun is probably the most important celestial body around us. It is responsible for life as we know it, and without its warmth, our beautiful planet would probably be a frozen wasteland devoid of intelligent life. Due to its extreme temperatures, it is a massive challenge to study it up close, so scientists must rely on data that is collectible here on Earth to better understand how it functions. The exciting thing is that a discovery made by NASA about the sun has shocked scientists everywhere. This exciting discovery comes thanks to the Parker Solar Probe and has allowed us to identify certain characteristics about the star, which were previously impossible to identify. In today's video, let's talk about these exciting new developments and the incredible probe which made it all possible. The Parker Solar Probe was launched by NASA in 2018 with the task of observing the outer corona of the sun. It is estimated to approach the star within 4.3 million miles from its center and is also expected to travel as fast as 430,000 miles per hour on its closest approach by 2025, a feat that will make it the fastest man-made object in history. The project was initially announced in 2009 with a total cost of around $1.5 billion. The craft was primarily designed by Johns Hopkins University Applied Physics Laboratory. The probe was named after nonagenarian physicist Eugene Newman Parker, making it the first spacecraft to be named after a living person. The probe weighs around 1,400 pounds, making it relatively light for a spacecraft, but it still needed to be launched to space aboard one of the most powerful rockets in existence, the United Launch Alliance Delta IV Heavy. This is because it takes a significant amount of energy to go to the sun. Data suggests that it takes around 55 times more energy to travel to the star than it does to go to Mars. The first stop for the probe was Venus. However, the only purpose of its visit to the planet was to perform a gravity assist to help it draw its orbit closer to the sun. The probe is expected to perform the same gravity assist multiple times throughout its 7-year mission to study the star. In December of 2021, it was announced that the Parker Solar Probe had become the first spacecraft in history to touch the sun. This is because the craft had successfully flown through the sun's upper atmosphere, called the corona, and sampled particles and magnetic fields there. This is a massive milestone, as the sun does not have a solid surface like the Earth, and the closest a craft can get to the star is in its upper atmosphere. This is an extreme environment that is roughly 2 million degrees Fahrenheit. The sun has a superheated atmosphere which is made of solar material bound to the star by gravity and magnetic forces. As rising heat and pressure pushes this material away from the sun, it eventually reaches a point where gravity and magnetic fields are too weak to contain it. This point is known as the Alfvén critical surface. It marks the end of the solar atmosphere and the beginning of the solar wind. Solar material that has the energy to make it across that boundary becomes the solar wind, which drags the magnetic field of the sun with it as it races across the solar system. It is important to note that the solar wind moves so fast when beyond the Alfvén critical surface that the waves within the wind cannot travel fast enough to make it back to the sun. Until now, researchers were unsure about the exact location of the Alfvén critical surface. Remote images of the corona suggested it lay somewhere between 10 and 20 solar radii from the surface of the sun. This is a window around 4.3 to 8.6 million miles wide. The spiral trajectory of the Parker Solar Probe brings it closer to the sun during each of its recent visits, with the craft being consistently below 20 solar radii on each pass. This puts it in a position to try and cross the boundary if the estimates are correct. In April of 2021, the probe completed its 8th flyby of the sun. During this flyby, the craft encountered the specific magnetic and particle conditions at around 8.1 million miles above the solar surface that told scientists it had crossed the Alfvén critical surface for the first time in history and finally entered the solar atmosphere. During the flyby, the probe was able to pass into and out of the corona on several occasions. This proved something that many had previously predicted. The Alfvén critical surface is not shaped like a smooth ball. It has spikes and valleys that wrinkle the surface. Discovering where these protrusions line up with the solar activity coming from the surface will help scientists learn how events on the sun affect the atmosphere and solar winds. This could have a significant impact on our understanding of how the sun influences life on Earth. The probe was able to dip to just around 6.5 million miles from the sun's surface at one point. Passing the star at this distance was similar to flying into the eye of a storm. At this range, the conditions are quiet. Particles are slowed, and the number of switchbacks significantly dropped. This is a dramatic change from the busy barrage of particles the craft usually encounters in the solar wind. This first pass through the corona, which lasted just around 5 hours, is a massive feat for the craft and engineers that helped build it. There are many other similar passes planned for the mission, as Parker will continue to spiral closer to the sun, eventually reaching as close as 3.83 million miles from its surface. The probe is expected to repeatedly pass through the corona in the many attempts yet to come over the next few years. Scientists are particularly excited to see what discoveries the craft makes on these future flybys. Even before the probe ever entered the corona, it was already sending back some extremely surprising data. On several solar encounters, the craft was able to collect data pinpointing the origin of zigzag-shaped structures in the solar wind called switchbacks. The data showed one spot where these switchbacks originate is located in the visible surface of the sun called the photosphere. By the time it reaches Earth, around 93 million miles away, the solar wind is an unrelenting headwind of particles and magnetic fields. But as it escapes the sun, that very solar wind is usually very structured and patchy. In the 1990s, a combined mission by NASA and the European Space Agency called the Ulysses flew over the sun's poles and discovered a handful of bizarre kinks in the solar wind's magnetic field lines. These switchbacks were initially thought to be oddities confirmed to the polar regions of the sun for decades. It wasn't until recently that the Parker Solar Probe discovered that switchbacks were not rare at all. They are a quite common occurrence. This renewed interest in the switchbacks raised new questions about their origin. Scientists were curious to know if they are forged on the surface of the sun or shaped by some process kinking magnetic fields in the solar atmosphere. Many of these questions were answered thanks to the Parker probe, as it provided data that showed switchbacks occur in patches and have a higher percentage of helium than other elements. The origins of these oddities were further narrowed when scientists found patches aligned with magnetic funnels that emerge from the photosphere of the sun. One important question that the Parker Solar Probe is expected to answer is the curious case of the hot corona of the sun. In defiance of all logic, observations have confirmed that the atmosphere of the star gets much hotter the farther it stretches from its blazing surface. Temperatures in the corona have been estimated to reach over 2 million degrees Fahrenheit. While traveling 1,000 miles deeper towards the surface, the temperature is a mere 10,000 degrees Fahrenheit. This strange occurrence remains one of the greatest unanswered questions of astrophysics, and scientists hope that the data collected by the probe will finally provide answers to put the coronal heating problem to rest. The mystery of coronal heating is more than 150 years old, and understanding how this happens is sure to advance our understanding of how stars behave across the universe. Scientists also hope to learn more about the superheated corona and what pushes the solar wind to supersonic speeds. This will help them understand and forecast space weather events that impact Earth's environment. Thank you for staying tuned. Hope you found today's video informative, and if you did, please check out our video on the importance of the sun and what would happen if it went out. Do you think the probe will survive its many trips to the sun, or will the heat prove to be too much? Please share your thoughts in the comment section below.